We've previously learned how to do gram-mole molecule conversions. Now we're going to take that one step further and do that for two related molecules that we can see the relationship from some balanced chemical equation. When we relate two molecules from a balanced chemical equation, this is referred to as a stoichiometry calculation. So let's consider this fake balanced equation there. If I was interested in molecule A2, as I said, I should be able to go from molecules, convert him into moles, and then convert that into grams. We learned how to do this before. Between molecules and moles, I use Avogadro's number, that's 6.022 times 10 to the 23rd. And to go between moles and grams, I use the molar mass, which we get from the periodic table. I could also do the same thing for molecule B, where if I wanted to, I could convert between molecules, moles, and grams. And again, this would be Avogadro's number, and between moles and grams, I would use the molar mass. Now, once I have a balanced chemical equation, I can actually go between these compounds by building a bridge between my moles. This balanced chemical equation tells me that for every 1 mole of A2 that I use up here, I'm going to use up 2 moles of B. So this is called a mole-to-mole ratio, and it allows me to convert between moles of one thing and moles of another. So I'm doing the same conversions I was doing before, but I'm going to make them a little longer sometimes, and I'm going to build a bridge between moles of two different things. So we'll look at an example problem in just a second, but the idea is we can use a map like this to figure out where I'm starting, where I want to end up, and how many steps that's going to take me. So let's look at first example. Sulfuric acid dissolves aluminum metal according to the following reaction. How many moles of aluminum, okay, so I'm going to start with aluminum, do you need to react with 4.32 moles of sulfuric acid? So notice it didn't mention the aluminum sulfate or the hydrogen gas, so I'm just going to ignore them while I work this problem. I only am ever relating two things in my chemical equation. I need the whole balanced chemical equation to see the relationships, so I'm just going to ignore anything that's not mentioned. So I'm starting with moles of sulfuric acid, and I want to end up in moles of aluminum. So if I go back up to my map, I can say, okay, I'm going to start with moles of one thing. I want to end up with moles of another, so that's going to be a one-step problem, and I'm going to use that mole-to-mole relationship in order to do it. So let's try it. Obviously, I'm going to start with my 4.32 moles of sulfuric acid, which is H2SO4. The moles of H2SO4, of course, have to go on the bottom, as with any conversion. And I want to go to moles of aluminum. So I put that up there. I'm going to use that mole-to-mole ratio, so I simply go up here and see what coefficients are next to each molecule. There is a 3 next to the H2SO4, and there is a 2 next to the aluminum. So the moles of H2SO4 would cancel. I would end up with moles of aluminum, and now I simply do the math, and I figure out that I would require 2.88 moles of aluminum to react with 4.32 moles of H2SO4. That's it. This is the only new step we're learning right now, is this mole-to-mole ratio from the balanced chemical equation. Now we can combine that with a longer problem, such as the ones we've been doing before. So, for example, same reaction, different question. What mass of aluminum sulfate, so I want to end up in grams of aluminum sulfate, would be produced by the reaction of 12.7 grams of aluminum with excess sulfuric acid? So when it says excess sulfuric acid, it's just saying assume I have more than enough of the sulfuric acid to react and just ignore him. We're going to learn later about limiting reactants, in which you figure out which reactant is going to run out first. So this is just telling you that you have more than enough sulfuric acid. You don't need to worry about him. And it doesn't mention hydrogen, so we're not going to worry about all of those guys. So we need to start with 12.7 grams of aluminum, and we want to end up with grams of aluminum sulfate. So if we go back to my map, Okay, we want to start with grams of aluminum in this case. We want to end with grams of my aluminum sulfate, so we can see this is going to be a three-step problem. First, I got to convert my grams to moles. Then I got to do the mole-to-mole ratio. And then I got to convert my new moles back to grams. So I should be able to do this in 3 steps. So it's very helpful to look at your map and figure out where you're starting and where you're ending up. Okay, so we're going to start with my 12.7 grams of aluminum. I said the first step was to go from grams to moles, so I'll get rid of my grams, turn this into moles of aluminum. So I'm just going to look on the periodic table to get that molar mass, and 1 mole is equal to 26.98 grams. So I've gone grams to moles. Now the second step was to go from moles of one thing to moles of the other. So I'm going to get rid of my moles of aluminum. That has to go in bottom. I want to turn it in to moles of aluminum sulfate. And I just look up here. There's a 2 next to the aluminum. No coefficient means that's just a 1 right there. The 1 is implied. So I've gotten rid of my grams of aluminum, got rid of my moles of aluminum. Now that I'm in moles, my third step is going to be to go back to grams, so I will get rid of my moles of aluminum sulfate. And I find it very helpful to always label what I'm talking about since I'm switching between 2 different molecules here. So 1 mole, and I need to figure out how many grams that is. So I'm going to go to the periodic table and add up 2 aluminums, 3 sulfurs, and 12 oxygens. So we should know by now how to get our molar mass. And that's going to be 342.147 grams. Now I've gotten rid of my moles of aluminum. So I'm going to do the math on that and end up with grams of my aluminum sulfate. And once I do this, I figure out that I'm going to produce 80.5 grams of my aluminum sulfate from a starting 12.7 grams of aluminum. Now if you look at that, you might think it disobeys the law of conservation of mass, but it doesn't, because remember there was sulfuric acid in there. We were just told we had enough of that to react, so we weren't bothered with it. That's it. That's all these stoichiometry problems are. There are gram-mole molecule conversions we did before, and the new piece is this mole-to-mole ratio. Now just imagine that instead of mass of aluminum sulfate, this would ask me how many molecules of aluminum sulfate. Just to imagine. If it had asked me for molecules, I would have done a similar thing. I would go up here and say I'm starting with grams of aluminum, but I want to end with molecules. I would go to grams to moles to moles, and then turn my moles into molecules this time. So just like we did gram-mole molecule before, I can still do it here. So I would do the same thing where I had 12.7 grams of aluminum. For every 26.98 grams of aluminum, I produce 1 mole. So I still go to moles first. My next step is still the mole-to-mole ratio, so I get rid of moles of aluminum and turn it into moles of aluminum sulfate. So for every 2 aluminums, there is 1 aluminum sulfate. But if I had wanted to go to molecules instead of mass, the only difference would be now that I'm in moles, I would get rid of my moles of aluminum sulfate, and I would use Avogadro's number, 6.022 times 10 to the 23rd molecules. Pretend it says molecules, and I would do the math. So if you want to go to molecules instead of grams, the only thing that's different is that last step. So really important is going back, always looking at your map, figuring out I'm starting here, I want to end up here, and think about what it takes to do those steps in between.